Alright, hello everyone, Assalamu alaikum. So, today I would like to share one definite integral which I just solved it just now, which for me is very interesting and I am willing to share. So, the definite integral given, which is from -1 up to 0, the square root of 1 plus y divided by 1 minus y. And if my explanation is a bit inaccurate, please do let me know so that I could notify of it and I'll fix it up later. But the way to solve this is that we first multiply the function inside the square root with 1, or we multiply it by the conjugate of the denominator. So we will write out as -1 up to 0 the square root of 1 plus y, 1, oops, 1 plus y divided by 1 minus y, 1 plus y. Okay, then after this, just expand, then you will obtain 1 plus y squared divided by 1 minus y squared. Now, before I move on, I would like to determine the domain on which the domain, this particular function will always be positive, and the lower upper boundary is in the domain, but I want to show you how to find out the domain first. So we know that this particular function will always be larger than or equal to 0. So what will be the domain? So 1 plus y divided by 1 minus y will always be larger than or equal to 0. So now, one of the methods to obtain the inequality is that we create a table. First, we create a real number line, and we're letting the terms to be equal to 0, then we plot it on the real number line. So here will be -1 and here will be 1. Now our left hand side will be our factors, 1 plus y, 1 minus y. Okay, so next is, pick a value between the numbers that you've stated here. So for example, maybe here will be -2. If you wanted to make it closer, it would be better, in my opinion. The closer the better, because there are some situations where um, this kind of choosing that particular number will not be precise. But in this situation, there should be no problem. Then the number between -1 and 1, maybe I want to choose 0, and then larger than 1 will be 2. Now, the values that I pick here, I substitute into these terms to determine the sign of the output. So the first one will be 1 minus 2 will be negative, the sign, and then the next will be the positive sign, and here the result will be negative. Negative times positive will be negative. And then the middle part will be positive, positive, which implies that we will obtain the positive sign. And then the last one will be the positive, negative, negative. Now these three signs, the way we want to determine which one we will be choosing is we will go back to the inequality here, and this states that it will be larger than or equal to 0. So the sign that will be chosen is here, which means that this region is the domain for the function. Now, before we write down, we have to know on which axis to find, because we want to know on which part will be the closed or open interval, whether it will be in a closed interval or from the endpoints, or one of the endpoints will be closed or open interval. So from here we know that when we substitute -1, it will be 0. So means that, okay, -1 can be included in the domain because it still satisfies the inequality. So it will be -1, and then 1, unfortunately, is undefined. Therefore, y can't be included, so we have to write the open interval. So the domain here, as you can see, it's in the lower and upper boundary for our integral. Therefore, we could continue the step by using one of the properties of square root, which means that let's say a, b are real numbers. And from here, we could separate the numerator and the denominator to become the square root of a divided by the square root of b. Okay, so anyway, by applying the properties for our integral here, we'll obtain the square root of 1 plus y squared, divided by the square root of 1 minus y squared dy. And from here, we know that the above will be the absolute value, because the square root of a squared number, a squared function, will be the absolute value for all x, which is in the real number. But here we know that this particular will always be positive no matter what. So we could ignore the absolute value. There are some cases where we could ignore it. It's based on the domain given, right? Therefore, we could just square it, then we can ignore that absolute value. Okay, so you can write it out like this: 1 plus y divided by the square root of 1 minus y squared. And now, one of the techniques of integration is that we will be separating the integrand. We know that we could separate this into two terms. The denominator here is only a single term. So once we separate them, we could solve the integral. Now, negative 4 up to 0 would be 1 divided by the square root of 1 minus y squared dy plus negative 1 0 for y divided by the square root of 1 minus y squared. Okay, so now we already separate our integrand. Now, for those who didn't recognize the first term, the integral there, is one of the basic formulas for the inverse trigonometry. And I know that the foundation students might recognize it, but I believe that metric students doesn't. Therefore, I'll say it first. It's not in your syllabus, but it's good to know for in the future. But anyway, this particular integral will give me arcsine. Arcsine stands for the inverse of sine x, but in this case it's y. So that's about it. But this particular integral, we have to solve by using use substitution, or if you're used to it, you could solve it directly. But for those who are new here, I'll be showing you how by using use substitution. So I'll be writing out as a definite integral. Okay, so I'll be doing it separately, then I'll solve it from there. So y divided by the square root of 1 minus y squared dy. And now we let 1 minus, we substitute the term 1 minus y squared, because when we take the first derivative, we could substitute the numerator. So let me show you what I'm talking about. So u is equal to 1 minus y squared du. We take the first derivative in respect of x, the respect of y, be negative 2y dy. And now we have to find the like terms so that we could perform the substitution. Therefore, it will be negative 1 over 2 du is equal to y dy. Now from here, know that negative 1 over 2 is a constant. We could bring it outside of the integral. We have negative 1 over 2. We integrate 1 over the square root of the square root of u du. And now solve it. So we obtain negative square root of u plus c. Right. And then you could substitute back 1 minus y squared plus c. Now, you already obtain your the resulting integral for your definite integral. But now we are focusing on, indefinite. Now we are focusing on definite integrals. So you could just refer to your resulting integral, which you did here, and just perform it directly from your definite integral. For this integral, if you recognize the formula, then you don't need to do anything about it. Okay, for the sake of the video, I'm going to show you how to solve it by using the terms of x. Alright, so the integral I'll be using the in-depth integrals. So how do we obtain um arcsine? By using trig substitution. So in this case, the proper trig substitution that we will be performed is replacing x with sine of x. Okay. Now x is equal to sine of, okay, another different term. Let me use t, sine of t. Then we take the first derivative, dx is equal to the cosine of t dt, and we substitute the term dx here, right? So this will become 1 divided by the square root of 1 minus sine square t. The here will be the cosine of t dt. Now, you have to refer back to, I believe that it is the one of the trig identities, sine square t plus cosine square t is equal to 1. And you express sine in terms of cosine. You have sine, sorry, you express it, you can express it in this form. Sine square t, sorry, cosine square t is equal to 1 minus sine square t. Okay, so now substitute 1 divided by the square root of cosine square t times with the cosine of t. And I believe that cosine t will always be positive no matter what. So this implies that you could get rid of the absolute value. Okay? Therefore, by simplifying it, you have the integral of 1 dt. Now, solve the integral, you have obtained t plus c. Okay, now what you're going to do is that you can express this term in terms of x. So by taking the inverse, you will obtain t is equal to the arcsine of x. Now, back to the result integral, resubstituting the value t will be the arcsine of x plus c. Now, here's how you obtain it. Okay, very nice. Now, with this information, you could apply it for your definite integrals. And from here, first you will obtain the arcsine of y, then place your boundaries here. Your upper boundary will be 0, -1, 0, -1, and then plus negative the square root of 1 minus y squared, and here will be 0, -1. Okay, so for educational purposes, I'll be graphing out the function for arcsine. So remember, the inverse function, fun fact about it is that for sine of x, we know that the domain generally is from -infinity up until infinity. But if you want to find the inverse, you have to restrict the domain first hand. Therefore, originally, when you restrict the domain, it has to satisfy one of the tests, which is the the horizontal line test. So the 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 sine function will be restricted in this form from if I remember, negative pi over 2 up until pi over 2, and the range will be 1, -1, 1. Okay, so from this graph, it satisfies the horizontal line test. Now, one of the ways to obtain sorry, obtained your graph for inverse function, you could use the function which is y is equal to x and reflect the function to obtain your inverse function. So the arcsine will be in this form. Okay, if I'm not mistaken, here will be pi over 2 and here will be negative pi over 2 y x 1. Okay, now This I just want to visualize on how I obtain those values of 0 and -1. Okay, so here arc of sine 0 minus arc of sine -1, then plus with -1 minus 0 square plus 1 minus -1 square. Now from here, by referring to the graph, arcsine of 0 will be 0. The arcsine of -1 will be negative pi over 2. But, well, a cool fact about this is that this function is a odd function, meaning that arcsine of negative x is equal to negative arcsine of x. So in other words, you can obtain plus arcsine 1, which is equivalent to pi over 2, plus pi over 2. So here plus pi over 2, and then the rest is trivial, nothing much about it, and then solved. Here you go. Here's your resulting integral. Okay, so it's a really interesting integral. It starts with multiplying by the form 1, which is by taking the conjugate of the denominator, and then from there you first obtain domain. Usually when we try to solve these integrals, you have to know your domain, including for trigonometry functions. It's very difficult, but the more you do, the more you get used to it. Anyway, from here you could separate integrand, and then you could recognize that the first part is the inverse of sine, and then the second term will be the use substitution, and then solve as usual. Also, we ignore the absolute value because this particular function will always be positive. So no matter what, in the domain given. So no matter what, you can ignore the absolute value, no problem. And then from here, I showed you how to solve for arc of sine of x, and then deriving the resulting integral for the square root of 1 minus x squared by using trig substitution and by obtaining pi over 2 minus 1. That should be your final answer. Okay, hopefully that will do for today, and I'll see you next time.